Right. So I'm gonna show you inside. See the prototyping board. See what's going on inside. So let's do this. There we go. Okay, so you can see here I have my Nano that's controlling the DAC here. This is a typical Adafruit MCP 4725, and then you got the ADS 1115 here. This is the current shunt I was talking about. Okay, it's for PCBs. It's they're basically connected in parallel, and it has a voltage. It has a it's a 50 millivolts. Okay, this is the small voltage divider. Both of these are fed into the ADS. Then it gets feed on the Arduino via I2C. Also the DAC, and then these are the connections for the display. Also I2C. This is the final stage operational amplifier. It's a typical quad amp. It's the LM324. Okay, and what it does here, basically, when you control it, it gives signal to the DAC. The DAC, in its own turn, feeds it through this operational amplifier that I'm using it as a buffer. Okay, so this one gives signal to the biggest for the control, and also it takes the readout for the initial current. So what it does, it basically picks the signal from one of these resistors right here. It doesn't even matter which one you pick it, just so you pick it. These ones that are basically connected to the four MOSFETs. And I also added uh, a feature from my previous attempts anyway. This small trimmer right here controls the maximum output of the final stage. So basically you can adjust it to 5, 10, 20, whatever you want. The other one controls the initial current setup. So if you have like very small trimming to do, you can either use this one or go straight inside the program. Okay. uh, this one, this is the gigantic diode that's used for the polarity protection. I decided to use like this one. I mean, shit, it's overkill. Okay, I didn't had enough space to fit it inside, so I figured I'm gonna use a gigantic one and get the show started. Uh, then the buffer that gets the initial current is just being fed from one of the analog input pins from Arduino. Also, I have another analog input pin for the thermocouple, which is right underneath. I didn't use the typical LM35. I wanted to do with a thermistor, because it it's very sensitive. I just find it to be more sensitive when it comes to temperature changes. Okay, and it works just by the thermistor. It's hooked to a voltage divider, resistor network, and I adjusted it, so it just gives me the range like a typical LM35 basically. Um, says the main 5 volts, then you have another one for the 12 volts, and then you have this one that is used for the fan, to control the fans. This is the gigantic buzzer, and everything underneath is just one big ass cooling system. This is just the typical plug for my two buttons in front of the display. and I have here or even here the input for the 12 volts power supply basically. And I'm using two fans. These fans are very good because they're very silent, and it manages to keep it between normal temperatures, so it's it's worked out pretty good so far. So I'm not even gonna attempt to modify anything about it at this point anyway. So well, next I'm gonna show you the schematic and show you the final PCB, and hope you like it. Stay tuned, peeps.